Right, so there hasn't been an update in a while on this. But I have done a fair amount. Recently anyway. In the last 2 weeks I've done more than I've done in the last year, because I finally decided to get off my arse, stop being lazy and do some work. So what we've got is, to start off with, you can probably see it's got new tyres. I hate changing motorbike tyres. Oh, it took like 3 hours to change the tyres because I don't have any tyre levers either. So I need to buy some of them next time. I have a halfway working front brake. By halfway I mean it stops fine, it just rubs because the pistons get stuck in the caliper, so I have to take the caliper apart at some point, but it works. Back brake isn't done yet. We also have this lovely setup here. If you look at those nice aluminium battery boxes, it's a nice steel, PVC coated steel conduit. Some nice 3D printed clips to hold on the wires. So I thought it wouldn't look particularly professional having just the orange wires coming out here. It did look alright, but this just looks so much better. I love the way the motor fits up in this as well. It looks amazing. Currently I've got the BMS wired up because these have finally arrived. These are Deutsch DT connectors. Bloody fortune those were. 16 quid each. But they're good connectors. They seal well. And I'm probably on my next project going to move completely away from these just because I don't know, they just don't seem quite right. And I very much prefer the Deutsch DT, even though I spend hundreds of quid, maybe 150 quid just on connectors. It's worth it because those will last. And as I said, I currently have the BMS running. None of the CAN bus electronics in the BMS are working yet. So I'll just quickly go and explain this stuff. So what we've got here is we've got 2 Arduinos and 2 MCP2515 CAN bus transceivers. One of them talks to the Sevcon. So basically this Arduino will receive data from the BMS, send it to the Sevcon, receive data from the Sevcon, send it to BMS, that sort of thing. This Arduino here, with this CAN chip, is just simply only for controlling the charger, because I got a charger with CAN bus rather than a charger with an enable signal, so I could set my own voltages. Because the enable chargers come pre-programmed in case I want to change the battery. I want flexibility. So this will work on a simple enable signal now. So this is basically just to control the charger, tell it what voltage to charge the packs to. And that will probably talk via SPI or I2C or something UART to this one. So the Sevcon will send, the Sevcon and BMS will talk to this. This will then tell the charger how to charge and what voltage to charge to, what current, whether to stop charging if it gets too cold or too warm, that sort of thing. And on the other side, now that we've done talking about that, let me just grab it. Bear with me. It's got a load of stuff just lying on top of it. Right, one moment. There we go. Had all the screws lying in it. On the other side of the bike, we've got, oh, it's very tight in here. On the other side of the bike, we've got this lovely chain mess here. Now I thought, as my mate very kindly demonstrated when we were putting this thing together, it's not nice to get your fingers caught in here when the wheels turned. Yeah, I had a very painful finger for the rest of that day, so I decided to put this thing together here, which has now got scratched because it fell on the floor. Decided to put together this lovely chain guard, which does indeed look rather fancy. Annoyingly, I stripped. I'm not exactly sure how, because I drilled the hole to the right size down here, and I tapped it with the right tap, but somehow it got stripped. So that hole doesn't function as a tapped hole. The other three do, so that should be fine. What else is there aside from all that? I think that is probably about it, except for that I'm back to the good old problem of Sevcon controllers being annoying, because you can't change the direction in software with the Sevcon. The default rotation direction for this Sevcon is clockwise, so the motor's spinning this way. Now if you think about that, say my chain is here, this is spinning this way, that will make the back wheel spin backwards, obviously. I want the sprocket on the front of the motor to spin this way, so I want it to spin counterclockwise, so it will rotate the rear wheel in a forwards direction. Otherwise I'll be going down the dual carriageway at 70 miles an hour in reverse, which, although it might sound rather funny, for me wouldn't be particularly useful. So this currently has absolute maximum acceleration. The acceleration looks insane, but just in reverse. So I'll have to figure out how to change direction, probably change some of the phase wires over again, change the hall sensor, maybe flip the hall encoder around the other way or something like that. And try and calibrate that with my oscilloscope, but we'll get there eventually. Also, the other thing is I've been on a few test rides with this, just round the block. And that controller, now, I've posted on Facebook with my next project that the Sevcon is water cooled. Lots of people said, "You're crazy, man, it's not going to get that hot." Well, let's say this much. That thing got up to 50 degrees just going around the block 10 times. Now, keep in mind, it is driving the motor incredibly inefficiently currently because the hall sensors aren't set up properly. And I might, in fact, bin that controller, get rid of it, use it for a different project, and put the sine cosine encoder back in that motor and get another size 4 that has sine cosine options. Because that way I get way more acceleration and far smoother acceleration as well. So there's currently one going on eBay, so I might buy that. Anyway, I'll keep this for now and see what I can do with it. What else is there? I can't remember what I was going to say now. There's something to do more about the thing going the wrong way. Mainly the problem being that if I can't change the rotation direction, it was about the efficiency. As I was saying, the motor spinning the wrong way means I have to put it in reverse gear to go forwards, and in forwards gear to go in reverse, which the controller doesn't seem to like, because in reverse, even if you turn the acceleration all the way up, you only get about quarter. So yeah, it's not great. Also, because it wasn't set up properly when I went around the block, the thing got up to about 55 degrees. The motor, even the motor considering that there is basically zero room for airflow around that motor, I was like, oh, it'll be fine. It's rated for 17 kilowatts and I'll only be using 11 peak, or 11 continuous, rather. I mean, that thing can do 44 peak and 17 continuous. So I was like, oh, I'll only be running 11 kilowatt peak. It won't get warm. It does get warm. So I might need to put a fan on the side. Same goes for the controller. I'm glad to say that the batteries are not a problem in the slightest, because even though that got warm and that got warm, and it was probably drawing about, let's say, 100 amp, the batteries, well, they didn't even get warm in the slightest, so I'm very happy with those so far. The things that got warm was the contactor, which is to be expected, the controller got very warm, and the motor got just barely, almost to the point where you can't feel it, but still slightly warm. So we'll just have to take a couple more test rides once the motor goes the right way and see if it does get warm. If it doesn't, then that's good. If it does, then I'll have to make changes again. But I think we're going in the right direction with this project. I'm just gonna tidy up the rest of this BMS wiring then try and get a new tank as well, because the old tank is kind of scratched and cut to pieces and it's got a couple of dents in it. So I want to get a new tank, drill the holes properly this time, because obviously now I know where everything goes. I don't have to do any experimentation. So hopefully this time it'll look a bit nicer. But yeah, also these batteries on the other side, if you bear with me, I actually drilled on this bottom box here. You see I drilled 2 holes to match up with the rear of the battery, so the battery can bolt on. I don't actually think I need to secure the batteries in these boxes, because if you look at that, there's like a couple of mil of play in there. It's like 5 mil of play. Up and down, obviously there's not going to be much play, because on this one, up is this direction, which will be affected during braking. So if I just pack some foam in there. Up on this one, going over bumps, it might bounce a little bit, so I'll put some foam in there, put some foam on the front, and then sandwich the front panel on. And I think that should be enough to retain the batteries from moving in the slightest, because they're heavy, they're not going anywhere. Should be fine. Otherwise I will drill some more holes to bolt them to the boxes. I don't think that's necessarily the best idea, but it's what I have. Anyway, I think that's about it. I don't think there's too much more to discuss on this until I start programming things on the Sevcon, and I will be doing a video about how to program a Sevcon when I get time for it, and once I get my recording gear set up on the PC, because there's been a lot of interest in how to program these. I know there are videos out there on how to program these, so mine may not be as good as those, but I don't think their video includes how to switch the direction. I will be including that on mine, hopefully, once I've actually figured out how to do it myself. If I can't figure it out, I will just get a sine, cosine one and make it spin the other way. But hopefully all the issues get resolved and then it will be working. Then I can take it for a proper test ride with acceleration better than 0 to 60 in about 5 minutes, because it doesn't pull away from a stop. It just, when you're pulling away, it takes about, it looks ridiculous. You have to waddle along to about 2 miles an hour and then give it loads of throttle and then it will accelerate. But once it's going about 10 miles an hour and you give it a fair bit of throttle, it pulls. It pulls about the same as my last bike, which was a hub motor. So that's already a good start, because that was it drawing about maybe 20 amps. This thing can draw, I think it's 500 phase amps and 300 battery amps for about a minute. Continuously it can do 120 battery amps and I think it's 300 phase amps, so that should be quite interesting. I think I'll only be needing about 150 amps or 130. For 11 kilowatts, I think it's about 130, 140 amps at most. So I'll be drawing 130 amps continuously, which is basically nothing for these batteries. They can do 500 amps easily. I think they're rated for somewhere like 250. But I mean, ideally I'd want to draw about 50 amps, because these were from an electric car. These are Nissan Leaf batteries, so I'm not exactly sure how much the Leaf draws, but I can figure that out. My mental maths is awful, so I can't figure it out in my head, but it's I think it's 300 volts, and it's 60 kilowatts, so I can figure out how many amps it draws, and see if I'm below or above the average current draw of these packs when they would have been in the Leaf. If I'm below, then that's good, because then they'll get even more life. So I'm drawing less than their rated continuous current draw. But anyway, I think that's about all. All I need to do next is sort out all the wiring, bolt things down, because DC-DC converter is it's between this battery and this battery box, and it's just sort of flopping around in the breeze, so I need to bolt that down. I need to do all the 12 volt wiring again, because I had all the 12 volt wiring done, but it was really janky and it looked absolutely awful. And I used spade connectors for everything, so I just cut all that off again and put some proper numbered cable on all the switches, and moved the DC-DC from here to under there. I need to sort out the regen braking, which I can't do until the motor's going the right way, because otherwise it will do weird stuff. I need to sort out lights and indicators, which is part of the 12 volt wiring. I've got those all. I need to try and figure out where I can find LED bulb replacements, because those headlights on there, that thing down there, draws about 140 watts. Actually, no more than that. One bulb on full beam draws 140 watts. So that's 280 watts. Actually, no, it is 140 watts, sorry, for the whole thing. So that cluster, that light cluster, draws 140 watts, which is quite a lot of power, including the rear lights, indicators and hazards, whatever. If I have all that running at once, that will probably draw 200 to 300 watts. And that's a lot of power just for lights. So I'm going to replace everything with LEDs, so that I'm down to, say, 25 watts. Probably, actually, it'd be more than that. It'd be more like 75 watts if I want bright front headlights. I might even get xenon headlights. But yeah, I think that's all there is to talk about, really. We'll see how the registration and testing goes, because you're not meant to cut the frame. As you can see, there is welds on the frame, and I drilled two 16mm holes here and two on the other side and welded bushings in. Now this shouldn't actually damage the structural integrity of the frame, as the point of a weld is for it to be stronger than the parent metal, and the bushing's made of the similar sort of steel as the frame. So it's basically as strong as it was, maybe stronger. Probably not stronger, but it's definitely as strong as it was. So I don't think that should alter the structural integrity, but we'll have to see what they think about that. And hopefully it passes, otherwise I'm a bit screwed because of the amount of time I've spent on this. The main problem I'm thinking is, if it doesn't pass and they say you have altered the frame to the point where it won't pass, I will have to get another bike, put all this same stuff on that other bike, but without drilling any holes or cutting anything off, which might be very difficult. But this whole battery, this battery box, and the motor are one unit. So if you undo these 4 bolts, 2 on this side, 2 on the other side, undo the 2 bolts holding the motor on, that whole thing will just drop out. So I could just literally take that out and bolt it straight into another bike, and there's my powertrain. That is the whole powertrain, except for the controller and one more battery. I would have quite liked to bolt the controller to the front of here, because then if worse comes to worse, I can just unbolt this and have my whole powertrain in this one unit. I'm probably going to be doing that for my next project, because that makes servicing so much easier, because I can just unbolt the whole powertrain, take it up to my workshop, because that's in the house. Can't take the bike in the house because getting a bike upstairs is not particularly fun. But I can take the powertrain into the house and fix it indoors where it's nice and warm, because it'll be winter soon here. But one other thing I would like to talk about is what I'm planning for my next project, which I'm thinking electric Mini Cooper. I'm thinking about getting a somewhere between a 60s and 80s Mini Cooper, and putting that other Sevcon Gen 4 in there and getting another one of these motors. But next time I'm going to get the ME1616, which is the water-cooled version of that. So I'll get that, stick it in the Mini, get this has 6, I'll probably get 12 or 20 even, and run it at 116 volts, and then have some fun. Because sadly the size 6 only supports up to 120 volts, whereas this can do 150. So I think I might have to go 24S still, which is 100 volts, because these come in modules of 4 cells each. So 24S plus 4 would be 28S then. And I'm not sure what voltage that is. I might just about get away with that, because 26S I know is 109 volts fully charged. So 28 would be somewhere along 118, 119, so that's awfully close to that 120 max, but I might just about get away with that. I'll probably go 28S and then just get 2 of these in parallel with each other, so that'd make and how many of these 28S? I think that'd be 7. So I mean I'd need 14 modules, which should give me about, this is 10 kilowatt hours, so that'd be 12, so that'd be 24 kilowatt hours, which for the weight is quite a lot. So I mean it'd probably weigh about 140 kilos for the battery, so that's not a lot for 24 kilowatt hours. That's the same as the older Nissan Leafs. So I think that'd be quite nice, and it'd definitely have plenty of power, because the Minis of that era, the 1960s, 80s, are absolutely tiny. I can barely fit in the bloody thing myself. So it'd just be a laugh, really. It'd be a very expensive laugh, but I think it'd be a really nice project to do, and I'd definitely enjoy it. But I'll have to wait and see what my plans are for the coming year, because I'm also thinking about doing a solar panel system. So I've got this little shed. I don't have industrial 3-phase power here, but I'm planning on expanding the shed a bit, getting a lathe, bigger welders, things like that, so I can do most of the work here. So I'm going to need 3-phase power. I could either apply to get 3-phase, which would probably cost me 20 grand, not doing that, or I could get 2 batteries from a Nissan Leaf, 48 kilowatt hours, stick them in a big box outside my shed, and get some panels on the roof, and then just put some 3-phase inverters on there. That'd give me as much power as I want. I'd just get a bigger inverter for however much power. I think that'd work quite well, really. Anyway, that's it for me.